Students, welcome back to our YouTube channel. My name is Teacher Martin, and today we are going to look at a question from X-rays, a chapter in Form 4 syllabus. The question reads, an X-ray tube operates at 18 kilovolts and the current through it is 4 milliamperes. Calculate A is the number of electrons striking the target per second, and B is the speed of electrons when they hit the target. Now we see the X-ray tube operating at 18 kilovolts. Now when the electrons are released from the cathode, they are given an external voltage which accelerates these electrons to the anode. And also we have current flowing through the X-ray tube, and that is 4 milliamperes, and we are supposed to calculate the number of electrons striking the target per second, and we are supposed to calculate the speed of electrons when they hit the target. Let's start with the first one. Now current passing through the X-ray tube is given by the number of electrons times the electronic charge. N is the number of electrons, I is current, and the E is electronic charge, which is given by 1.6 times 10 raised to power negative 19 coulombs. Now the first part, we are supposed to find the number of electrons striking the target. We come here and rearrange this formula. We get, if we make N the subject, we get N, which is the number of electrons, is given by current divided by electronic charge. Now looking at this value of current, it is milliamperes, meaning we must convert this value to the SI unit. And remember, the SI unit of current is amperes. We know 1000 milliamperes makes 1 ampere, therefore 4.0 milliamperes will be equal to 4.0 times 10 raised to power negative 3 amperes. Now having done that, we just substitute these values to our equation, and we get the number of electrons striking the target per second is 4 times 10 raised to power negative 3. There is a negative here, so there is a negative here. It's supposed to be negative 3 amperes, divided by electronic charge, which is 1.6 times 10 raised to power negative 19 coulombs, and this one will give you 2.5 times 10 raised to power 16 electrons. So we are done calculating part A, which is the number of electrons striking the target per second. So these are billions of electrons that are striking the target per second. Let us look at the second part of the question. You are supposed to find the speed of electrons. Remember, from this question we have an X-ray tube operating at 18 kilovolts. So this is a voltage that is given that accelerates electrons to the target. Now when electrons gain this voltage, it is converted to electric voltage, which is EV. Now this one is equal to this electronic voltage is converted to kinetic energy, which moves electrons to the target. Now we can have this formula. So electronic charge times voltage, and this V, capital V, is the external voltage, which is 18 kilovolts, will be converted to kinetic energy. So the total of this energy, the electric energy, is converted to kinetic energy, which moves electrons towards the target. So we have an equal sign because we have the whole of electric energy being converted to kinetic energy, and this V, small v, is the speed of electrons, and ME, we have the mass of the electrons given by 9.1 times 10 raised to power negative 31 kilograms. Now because we are looking at the speed, we can rearrange this equation. We'll be having if we multiply 2 here and 2 here, we'll be having 2 times EV will be equal to mass of electron times V square. Then V, which is the speed of electron, will be found by finding the square root of 2 EV divided by the mass of electron. Now, having this formula, we can just substitute the values. We know the electronic charge is 1.6 times 10 raised to power negative 19 coulombs, and voltage, the external voltage, the capital V is the external voltage, which is given by 18 kilovolts. We also convert that one to the SI unit, remembering the SI unit of voltage is V, capital V. So we convert 18 kilovolts to volts, and that one we multiply by 1000, we get it is 18,000 volts. Now we substitute all those values in this formula. So we know the M is the mass of an electron, which is given by 9.1 times 10 raised to power negative 31 kilograms, and V is the speed of electrons. So substituting these values, we get 2 times 1.6 times 10 raised to power negative 19 coulombs times 18,000 volts divided by 9.1 times 10 raised to power negative 31 kilogram, and we get the speed of electrons hitting the target to be 7.956 times 10 raised to power 7 meters per second. Thank you for watching this video. Make sure you subscribe, like, and comment, and also go back and watch the previous videos of our channel.